At 2300 hours on 5 June 1944, 18 RAF Lancaster bombers from 617 Squadron lifted off from RAF Woodhall Spa in Lincolnshire carrying no bombs whatsoever. Instead, each aircraft held bundles of aluminium strips, window in RAF Parliament, chaff to the Americans, cut precisely to 26.7 cm in length and 2 cm in width. Over the next 6 hours, these aircraft would fly a mathematically choreographed ballet across the English Channel, each plane executing a precise oval pattern measuring 11 km long by 3 km wide, releasing window bundles at intervals of exactly 4 seconds, whilst advancing towards the French coast at a speed of precisely 13 km/h. To German radar operators staring at their Würzburg and Freya screens between Kallala and Boulogne, this looked like nothing less than a massive invasion fleet of 10,000 tons, displacement steaming steadily towards Pas-de-Calais, the closest point between England and France, the obvious place for the Allies to land, precisely where Hitler and most of the German high command expected them. In reality, 250 km to the southwest, the actual invasion fleet of 6,939 vessels was approaching the Normandy beaches. The Germans were watching ghosts. This wasn't a desperate improvisation or a lucky accident. This was Operation Glimmer, the northern component of Operation Taxable, perhaps the most mathematically elegant deception in military history. The entire plan rested on a rather unsettling piece of knowledge. German radar couldn't tell the difference between a battleship and a cloud of tin foil falling through the air at the correct speed. What looked on paper like a hopeless gambit, convincing the entire German military that an invasion fleet existed using nothing more than aluminium scrap and geometry, became the template for electronic warfare for the next 8 decades. The paradox was this: the more sophisticated German radar technology became, the more vulnerable it was to being fooled by something as simple as metallized strips fluttering in the wind. Standard military thinking in 1944 held that radar had made large-scale deception effectively impossible. The Germans had deployed an extensive chain of coastal radar stations, the Himmelbett system, stretching from Norway to the Spanish border with concentrations of Würzburg, raised giant radars providing coverage every 40 km along the French coast. Each Würzburg installation could detect surface vessels at ranges exceeding 70 km and could measure range to within 100 m. German commanders believed this electronic fence made surprise virtually impossible. General Feldmarschall Gerd von Rundstedt, Commander-in-Chief West, stated in April 1944 that the English cannot put a single vessel to sea without our knowledge. The German 15th Army, positioned at Pardala with 19 divisions, maintained constant radar watch specifically because this stretch of coast just 34 km from Dover represented the most logical invasion route. German naval planning documents from May 1944 estimated they would have at least 4 hours warning of any major fleet movement, sufficient time to position U-boat, E-boat, and coastal artillery. The technical reality seemed to support this confidence. British intelligence, through ultra-intercepts and reports from the French resistance, knew precisely how good German radar had become. The Würzburg reinstallations used a 7.5 m parabolic dish operating at 53 cm wavelength, giving them extraordinary resolution for 1944. These sets could distinguish individual ships in a convoy and estimate tonnage based on return strength. Fighter control radars could vector night fighters onto individual bomber streams with lethal accuracy. RAF bomber command losses to German night fighters had reached catastrophic levels in 1943, with 1,047 heavy bombers lost between March and July alone, before the introduction of window dramatically reduced these figures. The German radar network represented a £500 million investment in 1944, roughly equivalent to $25 billion today. Critics of deception operations argued that this technological barrier couldn't be overcome with parlor tricks. Air Chief Marshal Sir Arthur Harris famously dismissed early deception proposals as conjurers' nonsense, insisting that radar had rendered such operations obsolete. Yet British planners at the London Controlling Section and the Special Means Department of MI5 believed something different. They'd been studying a peculiar phenomenon since July 1943, when window had first been deployed over Hamburg. The principle was embarrassingly simple. Radar works by sending out radio waves and measuring what bounces back. A metal object reflects radio waves. Thousands of metal objects properly deployed create thousands of reflections. The German operators at Hamburg had reported seeing what appeared to be hundreds of bombers where only dozens actually flew. The radar couldn't distinguish between a Lancaster and a bundle of metallized paper falling at the terminal velocity. What military theorists saw as radar's strength, its ability to detect anything metal, was simultaneously its fundamental vulnerability. The secret was in the mathematics, not the technology. Dr. Joan Curran, a physicist working at the Telecommunications Research Establishment in Malvern, had calculated the precise dimensions required for window strips to resonate at German radar frequencies back in 1942. The 26.7 cm length wasn't arbitrary. It represented exactly half the wavelength of German Würzburg radar operating at 53 cm. When radio waves of this frequency struck an aluminium strip of this precise length, the strip acted as a dipole antenna, absorbing the energy and radiating it with remarkable efficiency. A single bundle of window containing roughly 2,000 strips and weighing just 200 g produced a radar return equivalent to a bomber aircraft. Released at altitude, these bundles would separate and flutter downwards at approximately 300 meters per minute, creating a radar signature that persisted for several minutes as the strips dispersed. What actually mattered wasn't creating individual false targets. Any fool could toss metal out of an aircraft, but creating a coherent, believable pattern that would convince trained German radar operators they were watching an actual naval formation. This required solving an extraordinary geometric problem. How do you make falling aluminium strips which descend vertically at 300 m/minute appear to be ships traveling horizontally at 13 km/h? The answer came from Wing Commander Edward Dickey of 617 Squadron and scientists from the Telecommunications Research Establishment working together through April and May 1944. They devised a flight pattern where aircraft would fly precise oval racetrack patterns, releasing window continuously. Each aircraft would complete one oval every 30 minutes, with the oval advancing towards the coast at exactly 13 km/h, the speed of a heavily laden landing ship. The geometry was elegant but unforgiving. 8 aircraft flew the northern pattern, Operation Glimmer, creating the illusion of a 16 km wide convoy heading towards Ballon. Each Lancaster flew at 900 m altitude, releasing bundles through a special chute at 4-second intervals, one every 75 m of flight path. As the aircraft completed each circuit and began the next, it had advanced 6.5 km closer to France. To German radar operators watching continuously, this created the signature of a massive fleet advancing at invasion speed. The window clouds from successive passes would overlap, creating a dense continuous radar return stretching across kilom of ocean. The Lancasters had to maintain precisely 295 km/h airspeed, fly absolutely accurate rectangular patterns using H2S navigation radar, and hit their release timing within 2 seconds of the calculated mark. Navigation errors of more than 500 m would break the illusion. To make this work required more than mathematics. It required airmanship of the highest order. The Lancaster crews of 617 Squadron, famous for the Damasters raid, spent 3 weeks practicing the patterns over the North Sea. Squadron leader Leonard Sumter, who led one of the formations, later recalled, "We flew with our flight engineer calling out air speeds constantly. 2 knots too fast or too slow, and we'd be out of position." Meanwhile, The wireless operator was shoving window bundles down the chute like a factory worker watching his stopwatch. 4 seconds bundle, 4 seconds. Bundle for 6 hours straight. The physical act of pushing 2,000 bundles weighing 400 kg total through a narrow chute at precise intervals, whilst flying a precise pattern in darkness over enemy territory, transformed a clever scientific idea into a grueling operational reality. The window bundles froze solid at altitude. Crew members wore thick gloves and still ended the mission with bleeding hands from handling metallized paper in sub-zero temperatures. At 2:30 hours on D-Day morning, the German 15th Army radar station at Cap d'Antifer, 15 km north of La Haye, detected what appeared to be a major fleet formation 35 km offshore. The contact measured approximately 16 km wide,